let's keep on going. Look at more example. How do you solving for y and what is the value for x? So, oh, let's look at the next example. Next example. So in this, if the JK, look like JK, the arc is 80 degree. So they ask you what is the angle JMK. So JMK is inscribed angle, right? Inscribed angle is half of its intercepted arcs, right? So JMK, the inscribed arcs is 80 degrees. So half of 80 will be 40 degree. Will be 40 degree. Similar thing, if the MKS, the angle is 56 degrees. So this is an inverse question. The inscribed angle is 56 degree. It's inscribed angle because K is exactly, the vertex K is exactly on the circle. So that's a inscribed angle. So it will be half of its intercepted arcs. So 56 times by 2 equal 112. So the arcs is 112 degree. Let's keep on moving. So if two inscribed angle intercepted the same arcs, so okay, this question happened a lot. Okay, so let's see this arc. Okay, we can see this is a 72 degree. 72 degree. So is this blue angle a central the inscribed angle? Yes, it is because the vertex here is on the circle. So this blue angle is called a inscribed angle. Similarly, okay, so this red one is also the vertex is also on the circle. So it's also a same it is an inscribed angle. So as the definition we see is it, if the arc is 72 degrees, so this is 36. So if the arc is 72 degree, this is a 36 degree. So they both 36 degrees. So that means they are the exactly the same angle. They are congruent. They are congruent. Okay. Okay. So let's see the last question today. The last question today. Okay, in this circle J, okay, so that means J is, okay, so angle 3 here equal phi x. Let me write it down, phi x, angle 3 equal phi x, phi x, and angle 4 here equal 2x plus 9. So finding the value of x. So in this question, when you analyze this question, they only give you two information. So that is angle 3 and angle 4. So angle 3 and angle 4, they are only two information they give you. And they both include a variable. So that means you have to solve, in order to solving for x, you have to find some relationship between angle 3 and angle 4. So let's look at the angle 3 and angle 4. So angle 3 is a inscribed angle, right? Angle 4 is also a inscribed angle. They both have the same arc, intercepted arc of QD. So if angle 3 equal x, so the QD equal 10x. 10x. So let's see for the angle, if angle 4 equal 2x plus 9, then the QD equal 4x plus 18 is double of the inscribed angle. So that means no matter what, this two angle, you don't need to write in this one because you time by 2. We know because the arc is 2 times of its inscribed angle. So all we can find in the relationship is angle 3 and angle 4 are exactly congruent. So instead of writing 10x equal 4x plus 18, you can directly writing down phi x equal 2x plus 9. 2x plus 9. So to solving this, on both sides, you can subtract 2x. You subtract 2x, 5x, subtract 2x equal 3x. On the other side, 2x subtract 3x, 2x we cancel out, so it's only 9 left. So we can solve x equal 9 divided by 3, which equal 3. So in this case, 3 times by we plug x equals 3 inside. 3 times by 5 equal 15. So angle 3 equal 15 degree. Similar thing, we know angle 3 equal angle 4. So angle 4 also equal 15 degree. So let's see here. So finding the angle 4 we know is 15 degree. Finding the arc QD, we know the arc is double of its inscribed angle. So double of 15 degree. So 15 degree times by 2 equal 30 degree. The last thing, finding the arcs QTD. So QTD, let me draw it here. QTD, super large in arcs, right? So this arcs is almost a circle except the QD, right? So we know the for a whole circle is 360 degree, right? Whole circle is 360 degree. And the QD we just calculate, which equal double of the angle 4. The angle 4 is 15 degrees, so QD is 30. So 360 subtract 30, so which equal 330 degree. So that's it for today.